Everyone settle. I'll just wait for this. Till then, I will just ask how many of us are have worked on text before, any sort of text, like machine learning or NLP, just any text data ever. Okay, quite a huge number of hands. So this talk is majorly will be useful for you all and others as well. You'll get to learn what is like the basic challenge in a lot of textual problems, which is cleaning of data, and I'll talk a lot more about it in my presentation. So, as all of us will agree, we all know data science starts with cleaning of data. We get usually lot of data which is like misspelled, will have lot of indentation errors and other stuff like that. And usually what we have to do is we take this input of data, we actually see it, and we try to pre-process it to make it to a form where we can apply our models to it. Now this step is really important because you can't just take raw data and put a model to it. Your model will just fail miserably. Even though you might hyper tune your model using hyperparameters to be the best model, but if you're not doing good pre-processing enough, still your results won't be so good. So there is a famous Italian economist once known as Pareto, and he was in the 1900s, and he had come up with this Pareto principle, which he had told like in 80% of Italy, only 20% of the population stayed. So right now this 80-20 rule is a very important rule which plays in business as well. So which tells like 80% of the sales comes from 20% of the customers. Now this 80-20 rule applies in NLP as well. And I'm pretty sure those people who know this will be like the gathering of the raw data, cleaning data, and transform and feature engineering. Like those people who actually done or worked with text data before, they know the pain. Like 80% of your time will be going in all of these three things, and whereas just 20% will be on the training of the model and prediction, the actually evaluating the prediction quality. But what people don't realize is maybe what they say is according to the rule is this 80% of the time which it takes actually corresponds to 20% of your outputs, and this 20% will actually correspond to 80% of your outputs. But this 80% of your time which you spend on this, and maybe if it gives a less, like let's say 20% of your output, it's still really important to work upon the same. So in my talk, I'll be mostly focusing upon cleaning data and what is like the existing things which we use for cleaning data. Anyone? Anything? Spacey, pandas. Sorry? Yeah. Yeah. So like what I'll show you is basically first sample text. So this is like a raw text which I got from internet, and so yeah, backgammon, I don't even know the game, so please don't ask me questions about that. But yeah, backgammon is one of the oldest known board games, and this is like a raw text. What all can you guess you can pre-process this with? How can you make it a bit better, or before giving it to the machine? How do you think you can improve this text or pre-process it? Okay, good, 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 good. Anything else? All of these are correct answers, by the way. Yeah, I'm just like yeah. Okay. Anything else? Okay. So all of them are correct, as I said, and as far as I see, there are some things which are highlighted differently. So one thing, as you told about lemmatizing. So here, oldest and former. So both of them come from a lemma old. So ideally, if we want to give this model or give this text to a model, we want to lemmatize them both to old and then give. Other things are like board games and a game. So these two are basically the same thing. It's just that it's a plural and that's a singular. So you would want to basically capture on this game and the games, and it's a similar for player as well, with a P, with a capital P, and player here, and 2 there, as you can see, it's a digit 2, whereas 2 here is a like written 2. So ideally you want to convert those two also to a 2. So the common pre-processing steps which we usually face in NLP is first changing the occurrences of words with apostrophes and abbreviations. So if there was an it's written and an according like ACC, so you would want to convert your abbreviations to the full forms, and you would want to convert your words which has apostrophes with it is, so don't will become a do not and stuff like that. So these are one of the common text processing steps which happens. The next is to change all the case variations into a single form. So a players is ideally a player itself. A games is ideally a game itself. So that is also one of the pre-processing steps which we usually do. And the third is to change the synonyms to a common word. So oldest and former becomes an old, 2 symbol comma 2 will be 2. So in order to do these things, what we usually use is regular expressions, like to use this. And even in the beginning, when I was like, I had worked upon this 1 year ago, and I was facing, like, I had to do this pre-processing steps. So people were telling me, yeah, I mean, I knew, like, okay, I'll do with regular expressions. So, like, what's the harm? So, if the documents are in thousands, let's say in order of thousands, yes, regular expressions will get your job done. I mean, ideally regular expressions, for those who don't know, it's just a pattern to match characters. It's just a pattern, and it will get your work done. But what if there are tens of thousands and sometimes millions as well? So I was naive in the beginning. I thought, अरे regular expressions उस पे लगाते हैं, उस पे भी लगा ही देंगे. So I went ahead with that, and I didn't realize the problems which I would be facing with regular expressions until that moment. And when I sort of like tried it with like tens of thousands of documents and millions as well, I was literally like this. I was very shocked because I had estimated the time which it took for me. I had a corpus of around 3 million documents, and I had to replace 20k, around 20,000 keywords within that 3 million of documents. And the approximate time which it came to be will be taking 5 days. So as you know, I was doing my internship there for 6 months, and if I'm taking 5 days to run there, just a regular expression, for intern I'll have to keep on appending data and do this for future times. Surely I'll be just doing this before my internship ended. So I wanted a solution to come up very fast. So with this problem, introduced a sort of a solution which was known as FlashText. So FlashText is an open source GitHub which you can all search right now. Just search FlashText on GitHub, you'll find FlashText. What it does really good, is really efficient, is 2 use cases of it. First is searching words in a document. So let's say my name is Nandan Thakur, and I want to search Nandan and Thakur from that document, which is, let's say, only present in one document out of 10,000. So FlashText will be really good in that. FlashText is also really good in replacing the words as well. So let's say my name is Nandan Thakur to my name is, I don't know, PyData or something, but yeah, so it will replace that word Nandan Thakur to PyData as well. So FlashText, majority for these 2 use cases, it's really good, and it is built using the Aho-Korasik algorithm and the tree data structure approach, which I'll be talking about in detail after this. And the main important part was it reduced the computation time for 5 days for a regex to just 15 minutes for a corpus of the same thing. So that was really like helpful. That's the main reason why FlashText was built itself. And it's also written in pure Python. So how is FlashText so fast? So given, like, let's say we'll take an example. The sentence is, I like Python and Java, and the keywords are Python, Java, J2EE, and Ruby. So just a guess, how will you search these keywords inside sentence? Like any basic for loop or, yeah.
Okay,
Yeah, tokens and then, right? So you'll first check for Python whether it's present inside the sentence or not, then Java, then J2EE, then Ruby, similarly, and you'll check. So this is what regex does exactly. So it will take all your keywords which is there, which will be mentioned in your regular expression, and it will try to check all of them in the string. So for each word in keywords, it will check whether the word exists in the sentence or not. So that is what regex will do. Now how FlashText will do, at first I'll tell that is, it will check for each word in sentence whether it's present in keywords or not. So how this is better, if someone can guess or something iteratively? Yeah.
Keywords will be less than your corpus. The size of your corpus is large, so the number of keywords will be comparatively less than the size of the corpus.
Okay. So what if the number of keywords are more than the size of the corpus? So then would you suggest regex itself? Yeah. So my idea was, so all the keywords, right? So all the keywords are stored in a dictionary. So ideally, if you're searching a word from a sentence in a dictionary, how much time it will take? It takes O of 1, right? It's a hash table. On the other hand, when you are searching for each word in keywords within the sentence, that would take O of n square. Like O, it will take O of n. So that's why this method is very fast, because you're taking each word in the sentence and searching it in the keywords, rather than taking each word in the keywords and searching it in the sentence. Yep. It can be anything. Like, what if you have a 20,000 keywords and you just have 10 documents? Like, it can be anything, right? So ideally should, but that is what you define. So I can define what keywords I want to extract or replace, right? So if I want to replace 10,000 keywords which are only present in 10 documents, so yeah. Yeah. So keywords are basically just the words which you want to replace or search in a document. That is what your use case is. So if, let's say you have a text corpus of let's say sports, politics, and arts, let's say, okay, and you want to find Narendra Modi, how many times it has occurred in those documents. So you may have like 10,000 documents, and your keyword will be Narendra Modi, and for each document it will figure out whether Narendra Modi is present in the document or not. So Narendra Modi is a keyword which I predetermine, like I want to extract Narendra Modi if he's there.
So how would you generate
We give it. So yeah, I'll be coming to that. So we only will be feeding keywords. So yeah, so how the dictionary is stored is based upon a tree dictionary structure. It is nothing but very simple. So it stores the words by character level. So let's say you have Java and you have J2EE. Sorry. So it will store JAVA, and then since J comes in J2EE as well in the first character, so it stores J2EE like that. So as an example, if let's say I want to add PyTorch to it, so it will come here. Okay, sorry, it will come PYTORCH at the end of T. So here the start means it can be anything. It can be a space, it can be a line break, or it can be a new line. And the EOT means the end of the tree. So that can also be either a space or a break of the line. So it can be a line break, it can be a space, or it can be a full stop. So now what happens in a Karosik algorithm is like, just consider that initial case of the FlashText. Now instead of searching by word, now you try to search by character from the input text. So if you're searching by character now, you'll start with a line break in the beginning, which is the start, and then there is I, and then it will, since your dictionary is there, so it will start with the end E of T, then it will see there is no I, so it will immediately break off. And similarly for like as well, so then EOT, and then it will again go at the start, because again it will be having a space. So then if there is space, then it sees LIKE for like. There is no L in the beginning itself, so it will again break off. For Python, it checks all the each characters individually, so it will check P, Y, it will check your P, Y, T, H, O, N and E end of the tree, and since it finds the full thing, it will either extract the key which is there for present for Python, and similarly for and Java. So our text was I like Python and Java with spaces and breaks. So it goes each character one by one and checks whether we are getting the full, what do you say, the word which is present in the tree dictionary or not. So now just to compare the time complexities.
Just one second.
Sorry.
Taken as it is or any pre-processing stuff?
No, right now there is, let's say,
You suppose a small PYT is there.
yeah.
But in your tree, you define that from the capital PYT.
Correct.
Will you stay true or
Yes, yes, I'll come to that. So what you can do is, let's say if you're defined as capital P Y T H O N, right? You can define that capital P Y T H O N, sorry, Python, and the correct substring will be the small P Y T H O N. So it will search for the capital P Y T H O N, but if you want, you'll get the what do you say, the clean name. Okay, yeah, I'll come to that as well. I'll show you. So time complexities. So let's just take a basic example of this is an input text he, shers, and in our keywords we have he, she, hers, and his. So this is what we're searching for in input. So basically, imagine we have an array of keywords, what do you say, keywords, and n be the length of the input text, like the total full corpus input text, and length meaning length of each character. So joining all characters, what will be our input length text, and m be the total number of characters in the all the words. So m here will be h 1, 2, 3, 4, 3. So 6, 10, 12. So m is the length of the characters in all the words, the sum of that, and c is the total number of occurrences of these words in the text. So what you can guess will be the time complexity for a regex to take this, a basic guess with these, with k and m. Anyone? Okay, so so since it will search one by one the word in the text, and the text is of n length, and you will be searching all the keywords from it. So it will be a complexity of n into k and plus m, because you have to search the additional characters as well along with that. So this is the time complexity for a regex. And now what will be the time complexity for the Aho-Korosek algorithm, or which is implemented in the FlashText? Okay, so yeah, I mean it's not so intuitive to calculate this one. So it is O of n plus m plus z. So you will take O of n to actually build your tree dictionary. So it will go through each and every word from your input corpus of n characters and build that dictionary. And then from that dictionary with m, since m is the total number of characters, so m plus z will be the complexity to find the particular all the words from the dictionary, from the tree dictionary. O of n is to create the tree dictionary, m plus z is the to basically search the word from the dictionary. So that's why it's O of n plus z. If you sort of like are confused right now, you can like check up on this online, you'll basically understand. And yeah, so the good thing about regex is it used to search one by one all the words in the text, but in FlashText what is happening is it is searching all the words together at once, because since you're putting your input text into the keywords, it will give you all the keywords at once. So on GitHub, just it is publicly available, library. You just have to do pip install FlashText and it will get installed for you. On GitHub, it has more than 2,500 stars, and on Medium, my mentor had wrote an article on Medium which has received over 15,000 claps. And even Radim Rahurek, those people who know him, he's the founder of Rare Technologies. He's the person who's created Gensim. He had also basically tweeted about FlashText as well, and he's quite a big person. So, like, that's here. So a basic example for how you'll use FlashText to searching keywords, and now I'll come to your query, was as yours as well. So from FlashText, you just need to import a keyword processor, then you instantiate your keyword processor. Then what you're doing is you're adding just keywords to it. So here you're adding your unclean name and then the standardized name. So let's say I put P capital, Y small, T capital, Python like that. And then the clean name which I want is just Python for that. And similarly for Python, I've kept it. So let's say if I want to extract keywords now, so it will search this PYTHON which is there present there, and since that is the standardized name to this, so I am getting extracted as Python as my top as the keywords. And Java, since it is found Java, and the clean name also I have not defined, so it will just see that this is only the clean name which is present, so it will just give me Java like that. So this is how you can extract keywords from keyword processor. So yeah.
It's not like you don't search for but like PY.PHP. That's like searching for infinite number of keywords at once.
Yeah.
How do you provide the keyword based search?
Yeah, it's not. It. I will come to that. That's a limitation of FlashText. So FlashText is for a use case in which you know what the words you want to search for. So you will have to know. So for my use case, I knew pre-hand what all I had to search for. I had that corpus, but only that there were a lot of documents, and if I had to search with that corpus with all the things which I know which I want as the output, it was taking me a lot of time. But again, the problem which you are telling can be only solved with regex. I will be coming to that in your limitations. But you understand how I give keywords, right? So I will only manually input all the keywords which are present there.
What you are doing?
Yes.
Capital. In another case, if H is capital, then I have to add one more keyword in this list.
Yes. Yes.
I have to keep on adding all the variations.
Yes.
Right?
Yes. So you'll have to see in your raw text what sort of variations are there. I mean, that part you'll have to figure out what all keys you're getting at least. So that is it. Or if the problem is just lowercase or uppercase, what we anyways do is in the pre-processing step we convert everything to lowercase.
Right.
If that is the only problem, but this can be used for, as I told, the initial three things. If you have to convert its to it is, or you have to convert lemmatizing also really works here when you have a huge corpus and you know the words from before. That's the thing. You should know the words from before what you want to extract from. So this was a search performance which was done between regex and FlashText. The small red line which you can see below, that is actually the time taken for FlashText, and since it's O of 1, so basically you keep on giving number of terms, it will not increase. It is just constant. On the other hand, the regex is linearly increasing in this case. So for replacing keywords also, it's almost the same. You first instantiate your keyword processor, and you say, okay, I want to replace this word with this word. So if it finds in the sentence the one word which you want to replace, so it will replace. So I wrote I love Python 2.7, then I changed it with Python 3.5, and it came as I love Python 3.5. So that's how a basic example for how to use replacing keywords. And also similarly for replace performance, we have again FlashText. If you can see, it's a small red line, but in terms of comparison, it will linearly increase for regex, and whereas it is constant for FlashText even if you give a huge number of terms and documents. So question is, when do we choose FlashText? In terms of, we did one analysis in terms of the number of terms taken and the time it was taking. So we found out that roughly FlashText starts to outperforming regex if you have more than 500 keywords. But again, this depends upon what the document size is again. But this is like a base which we found out. So if you have very less documents, you can use regex. But again, like I would suggest use FlashText. So limitations in FlashText, like what you told. So FlashText you cannot match partial words like word to vec. Then because if you start matching partial words, then your whole purpose of FlashText becomes defeated, because you'll have to again search back in the text with the word and get all the possibilities which are there. So what you can do is, instead, if you can get all the regexes which you want. So let's say a word /d vec will correspond into all the digits which are there present in word to vec. So if you can just put that in your input keywords and then process that basically put that in your dictionary and then search that within your text. So that could help you, but again, I would say this as a limitation of FlashText, because if you want to do match partial words, then you will have to search for the word inside the text itself, which we want to do the opposite of things so that we can save on time. So regex can search for keyword-based special characters as well, which is currently not supported in FlashText. Like you can search for dollar, as you all told, and so the time complexity can increase quadratic if you have words like that, because it will search for A and then it will again go to A, and then it has to go to this as well. So like the time complexity can be quadratic, but these cases are very rare unless someone is doing a very big mistake with the dictionary.
So, for getting input of keywords,
Yeah.
if you have to give suppose the word 0 vec to word 9 vec, you have to write like different add keywords.
Yeah. You can.
Does it not accept as a place for?
Yeah. You can just do a for loop. Store all the things in a keywords. Just do a for loop in that and add it. Fine, right? Yeah. So what usually people do is we initially also define our own dictionary. So we'll have like a unclean name with the clean name. So you loop through the dictionary and just put it there. So key takeaways, mostly FlashText helps in if you want to search and replace keywords, and it is way more faster than regex if you have a very big corpus and where you have to extract a lot of keywords. If your daily job involves dealing with problem of text cleaning and modifications, then FlashText will help you out, apart from other pre-processing steps which you anyways have to take. People working with text data, entity recognition, natural language processing, or word2vec would benefit a lot from FlashText. So I was personally working on a word2vec, and my problem was when I was using the word2vec initially, when there was no FlashText, I would find that JavaScript, a small JavaScript vector, is very closely related to a JavaScript with a capital J vector. So like with just capital J in the beginning. So that's from there we realized it's such a big problem. Which is solving for us. Maybe in future, if you guys have such a problem, it will be helpful if FlashText help you out, and I'll be also really happy for that. So yeah, thank you. This is me. I'm currently working as a software developer in Northscape, and previously I've worked as a research trainee in EMBL, which is in Germany, and I've worked as a data science intern as well in Belong. So in Belong, where I had worked upon this FlashText with my mentor. My mentor is solely responsible. He was the creator of this package. At that point of time, I hardly knew Python as well. So myself, I was learning, I was helping him out, but I have no, name related to the package as well. It's my mentors who has developed it, and he maintains it. So yeah, thank you. I would like to appreciate the organizers here once, and because I feel like the meetups which they're doing are really nice, and also I would like to just say a few words. Like I feel everyone should come up with a talk, or at least try to, because the last time meetup I was talking to Nandan, and he had told me we have a lot of time in a day, but we are in short lazy to actually do some things, and we end up not doing it. Like a side project, everyone has time. Like everyone just makes excuses to not do it. So this time I thought that time, I'll just give a talk and let's see how it goes. So I've applied for 2 more talks elsewhere. So whenever time I get, I'm trying to utilize it, and I expect if everyone could at least give it a shot, so it will be really good. So yeah, thanks a lot. Any questions? Yeah.
Operations will regexes like RE5 or anything that
Yep.
find the position and all. Can we do with the flashback, or is just for searching and
No, So that's what FlashText mein you'll have to know what keywords you're searching from before. So if I can give the list of all the words which you want to search after you've used regex, then you can do, but that's why it doesn't allow partial string matching. Partial word matching it won't allow.
Okay, so the other operations of whatever I'm getting in the regex functionality.
So let's say this won't be a good example for if you want to extract out URLs out of a thing. So you can have a lot of URLs. So this won't be a good method. I mean, I would say FlashText won't support your cause. Then you'll have to use regex itself. So yeah.
How much is the memory prepared for this? Isn't it saying 38?
Yeah. So it's so the memory which takes for the tree is m into n. So it creates that. It's a memory on memory base. It's O of mn.
So like when you use it, was it like considerable as would it work on?
No, yeah. It will. Okay, 3 million and 20K won't work on your laptop. So I mean, in Belong when I used to work, they had a GPU. So we used to keep all our stuff there, process there. You can try working it in your laptop, but then that is a very big corpus. Your laptop will hang immediately.
To give some context, if you're using a standard corpus like gigabyte corpus, you cannot load them in your laptops anyway. But if you're using a smaller corpus like a Reuters file or B5 corpus, which you can load into a RAM, FlashText takes about half GB of memory to render that. So you can definitely do it in your laptop.
Anyone else? Yep.
You also mentioned like the last case AAA.
Yeah.
So is it like suppose it was like 8, so 8 itself 8C anything. So would that also fall in that category?
Sorry, I didn't hear you. You said 8 A's together.
I'm saying that so we're talking, so if you have a same number, right?
Yep.
Suppose 8,
Yes.
so it is 8 itself,
Yeah.
8C anything.
Yes.
So will that case come up in this case that AAA because it will branch out of tree in the
Yeah. So the case for this is let's say you have you have given 3 strings. Okay. Let's say I want to search my name is Nandan Thakur. My first keyword is my name is Nandan Thakur. Second is my name is NANDAN. Remove the R, and let's say you've given all the keywords like that. So ideally in that case it's like the worst it can go, because for each and every word it is going through till the end and it will extract all the keywords out. So yeah. Yeah.
So in Java and Python, strings are immutable.
Yeah.
So are you sure they are comparing two strings or going on both ends?
Yeah, you can.
They are, if they are immutable,
No, we're not changing the string itself. We're just like.
yeah. So
Sorry.
if we are in two strings and we compare, both are immutable. I don't think they go. So that can be less.
Yeah. So in terms of regex, the problem there was for each and every keyword you have to search through all the full document. So that's why. So it is depending upon the number of keywords you have. It is going to proportionally increase for that, as I mentioned.
Yeah, it will be then n into k.
Yes. Yeah. Yeah. N into K is like.
Can you go to the graph for data set here? So this way, will it where, I mean, you can explain it.
Yeah.
We'll go to cost and then E and then we'll.
Yeah, so-
we'll go to a node or.
Okay.
it is not
Okay, I'll
going to
explain
come
this.
to next.
Sure.
Next step.
Sure. So I'll explain this. Initially, how this will be creating is when you'll be giving your keywords Python, Java, Python. By that time, it will create the dictionary. So it will create your dictionary according to that. Let's say for this case, we had 4 keywords: Python, Java, J2EE, Ruby. So it created the dictionary. And now what will it will do is it will go through each and every character which is there present in your text. So each and every character. So this is a break line, first very beginning. So first very beginning was a break line, then it went to I. but then you see there is no height.
So
So
we do a round robin of space.
yeah, so that way also it is really good. It doesn't have to search through all the characters of your words. So it will just check whether each and every character are present in your first character or not. So it will immediately break off wherever it sees it's not the first character, or correspondingly second and third.
Do you think it is removing the complexity where all of the keywords are not being, let's say, we are not going to mention each and every keyword, but then to length of the keyword, their complexity are listed.
Yeah, so it is there here as well.
And it will be repeated, yeah, it will be repeated with each and every
Yeah,
text
so
too, right?
so M is the basically the total number of characters in all the words which are there in your keywords. So M, it's a linear function of M here as well. It's a linear function of M there as well.
So then you cannot have plus, but it will be one of each of your keywords, then you have
So
one.
no, we're not iterating through
Best
keywords.
case for we are not getting length with each and every character.
We're just iterating through the text only once. That's it. For, yeah.
Text only once.
Yeah.
But for that graph, first it will compare that text with the V, and then come to Y or seven. There's no matching, right?
Yeah, but that can go max till M.
Yeah, and that is the length of all of the keywords, right?
Yeah, but that, yeah.
Then it will come to next character.
But your initial loop was of N going.
Yeah, and then it will come to next character.
Yeah.
Then how it will?
No.
Will it again match those keywords?
But you're so the text you're iterating through, it will just try to catch all the keywords which are present once you're going from beginning to the end of the text at once, at one go.
Yes.
So in order to do that, you're going through n characters.
Yeah, you are going to talk about the choice.
Yeah.
So it will compare each and every
Character.
right?
Yes.
First character of each and every character.
Yes.
You want to start. If it is a fine, then it will come to next, right?
Yes.
Then it will again.
Yeah. So let's say.
Graph, right?
Yeah.
Quick interruption. One, it's not a comparable of it, you can go direct to the two. I think this one we want to keep it to what the try the data structure is. So maybe we can take that offline, and if there are more questions around text also strength certain, we take them further. Right.
Cool. Thank you.
We have lightning talk on Twitter now. Lightning talk is like a 5-minute talk. So if anyone else wants to get a lightning talk, please just connect it.